All right. All right, so today we're going to name our alkenes and alkynes. We did a little bit of that last time. All right, so rules for naming your alkenes and your alkynes. All right, so you got to find the longest carbon chain, and that longest carbon chain has to include the double or triple bond, and that double or triple bond has to have the lowest number possible. All right, so you got to find the longest continuous chain, all right, that contains the multiple bond, whether it's an alkene or an alkyne, a double bond or a triple bond. And of course, if it's an alkene, it's going to end in ene. If it's an alkyne, it's going to end in yne. And you know the difference because an alkene has a double bond and an alkyne has a triple bond. All right, so you number from the end nearest to your multiple bond because that will give it the lowest number possible. So lowest number possible for your double bond or triple bond. Your branch changed are your alkyl groups. They're named using the same method as we did our alkanes with the number and the name of that group. All right, so again, a 2-carbon chain would be ethane. When you have a double bond, then the end is ene. This is ethene. Note that on ethene, you don't need 1-ethene because there's no such thing as a 2-ethene. All right, but if you wrote a 1-ethene, I would not count that wrong. That would be full credit. Sometimes if you don't put the 1, like in a butene, if it's 1-butene and you don't have the 1, then it's the wrong answer. Common name for this ethene is ethylene, and what we do with ethylene is we polymerize it to give us our polyethylene. All right, so we're going to name some of these alkenes and our alkynes. But in your alkenes, note that your alkenes some of them may have a cis or a trans geometric isomer. All right, your alkynes will not have this geometric isomer, but the alkene will have the cis and trans possibility for an isomer. All right, so if we look at naming this alkene, I immediately see that on this side of the double bond, I have 2 H's. When you have the same group on one side of your carbon-carbon double bonds, then you cannot have cis and trans isomers. So this tells me no cis-trans. All right, because you have 2 H's on the left side. The right side would be fine because it has an H and then it has this butyl group. So it would have 2 different things on this side, but this side has the same thing. And so there's no cis-trans. So we're going to find our longest continuous carbon chain. That is a 1, 2, 3, 4, and 5. And of course, you could number it the other way, but we want the lowest number for the double bond. So we're always going to start numbering at the end closest to the double bond. All right, so 5 is a pentane, except this has a double bond. So we know that that is a pentene. All right, and you have to put the number for the first carbon on the carbon-carbon double bond. And so that is a 1-pentene. You also notice off of carbon 3, you have a methyl group. So this is a 3-methyl, 1-pentene. All right, and so anytime you have a number and a letter, you have to have a dash. So 3-methyl-1-pentene. All right, is the way that you will name this alkene. All right, here we have triple bonds, so we have alkynes. And so again, longest continuous carbon chain, here is 3, but you always start at the end that is closest to the double or triple bond. And so I'm going to number it 1, 2, and 3. If you would number it 1, 2, 3 the other way, then the triple bond would start at carbon 2. If you number it the end closest to the triple bond, it starts at 1. Now, this is a propyne. It would have been a propane, except it is a triple bond, so it is a propyne. So YNE tells us that it is an alkyne and has a carbon-carbon triple bond. All right, the 1 is not necessary because there's no such thing as a 2-propyne. All right. Again, if you put the 1 here, I'm not going to count it wrong. So if you put 1-propyne, that is fine. But propyne does not need a 1. All right, so the next one is very interesting because this one will catch people getting the wrong answer. All right, because you are finding the longest continuous carbon chain. And 4 is not the longest continuous carbon chain. All right, looks like I just wrote to 4. Yes, I did, but that is not the longest continuous carbon chain. 1, 2, 3, you could go down here for 4, and now you have a continuous chain of 5 carbons. So that continuous chain can go down, it can go up, it can go left, it can go right, wherever it goes, but you're not picking up your pencil. Continuous means that you don't have to pick up your pencil to get to the next carbon. All right, so a continuous carbon chain. So you can go down, you can go up, you can go left, you can go right, you can go anywhere, just as long as you don't have to pick it up. I can't get to 6 unless I pick up my pen and say, okay, well, then this methyl has to be named as a group. And so 4 is not the longest carbon chain. 5 is the longest carbon chain. So that would be a pentane. But we see we have a triple bond. So this is not pentane. It is pentyne. YNE. And here you can have a 1-pentyne. You can have a 2-pentyne. You can have a 3-pentyne. So you must put the 1. So here, if you don't put the 1, you got the wrong answer. Here, if you don't put the 1, well, that is the correct answer. But if you put the 1, I will not count it wrong. And off of carbon 3, we have a methyl group. So you have to put a 3-methyl 1-pentyne for the name of that one. All right, so sometimes the numbers are not required. Sometimes they are required. If you put it and it's not required, I'm not going to take off. If you don't put it and it's required, you have the wrong name. All right, so when we have a benzene, so remember you have a benzene that is alternating single and double bonds on a 6-membered ring. And as I said, and as they're showing, most of the time it's shown with a circle in the middle because that is showing a resonance hybrid. If you put an ethyl group off of a benzene, then you have ethyl benzene. So this is an ethyl benzene. Now, when you're naming your benzene rings, if you have 2 and you only have 2 groups coming off of your benzene ring, then you can use the naming system of ortho, meta, and para. All right, so ortho is going to have a lowercase o, meta has a lowercase m, and para has a lowercase p. So if you're numbering this, the numbers would be those lowest numbers possible. On a ring, you can start number 1 anywhere you want. So the lowest numbers possible for these 2 methyls is a 1, 2. So this would be a 1, 2 dimethyl benzene. All right, and so you now know that ortho means 1, 2. In a number system, it is 1, 2. In a naming system of ortho meta para, that is an ortho dimethyl benzene. And the complete common name for this would be a xylene. You do not need to know that xylene means dimethyl ether, but xylene means dimethyl benzene, sorry. All right, so you have your dimethyl benzene is a xylene. All right, so here when we number it, lowest numbers possible, you have a 1,3 dimethylbenzene. So you need to know that meta means 1,3. And then para here, lowest numbers possible are 1,4. Now, of course, just like you could number it the other way, does that have to be 1 and that 2? No, you could number it counterclockwise. That's 1 and that's 2, but still the lowest numbers are 1, 2. You can number this one 1, 2, and 3. Again, the lowest numbers are 1 and 3. Here you can go all kinds of different ways. You can start here 1, 2, 3, 4. It's still 1, 4, or 1, 2, 3, 4. It's still 1, 4. But the way you would not go is 1, 2, 3, 4, and 5 and call this a 1, 5. That's not the lowest numbers. The lowest numbers are 1, 3. All right, so 1, 3 is a meta dimethylbenzene, and then finally a 1, 4 dimethylbenzene is a para dimethylbenzene. So you have to know that 1, 2 is ortho, 1, 3 is meta, and 1, 4 is para. And it has to be exactly 2 groups. If there is less than 2, if there's more than 2, you cannot use ortho, meta, para. When there's 2 and only 2 groups on your benzene ring, can you use ortho, meta, and para? All right, so let's go back to this one. All right, so let's go through the naming of hydrocarbons. So again, you're finding the longest continuous chain of carbon atoms. All right, so that's what we always will start with. However, when you're talking about an alkene or an alkyne, that longest continuous chain has to contain the double or triple bond. When we do our functional groups, that longest carbon chain has to include our functional group in that chain. All right. And so you name any chain branching off as an alkyl group. So remember, you have your alkane. And if you take off a hydrogen, then you have alkyl. So we had methane, and then we had methyl. All right. And so then we're going to see that we're going to have ethyl, because we're going to have our ethane. And then we take a hydrogen off, CH3, CH2. We're going to have ethyl. All right, so your ane goes to YL when you take off an H. So this is your ethane. All right, you take off one of the H's, and now you have ethyl. All right, so if you have carbons that are not part of the longest carbon chain, you're going to name those as alkyl groups. And you're going to put the number of the carbon that is coming off of. That's how you're going to locate that group. And of course, you want the lowest number possible for the first alkyl group. And again, if you have more than one of the same alkyl group, if you have 2 of them, use di, 3 of them, tri, 4 of them, tetra, 5, penta, etc., etc. All right, so we have our alkyl groups to memorize. All right, and so here is a alkyl group chart. It is an incomplete chart. There's a couple of them that we need to add to this. But if you have, we already know this one. We had methane, we took off an H, and we had methyl. So you have to know that CH3 is a methyl group. The one that I just did was ethane, take off an H, and you have an ethyl group. All right, so that's going to be the same for all of your alkyl groups. You take a hydrogen off of propane and you have propyl. However, when you look at propane, you've got 6 hydrogens that are the same. The methyls on the end are the same, but you also have hydrogens in the middle that are different, and that's why propane was listed twice here. All right, so if you take off the hydrogen in the middle, all right, now you have an isomer of the propyl group, and that is called isopropyl. All right, so to distinguish them, I will normally put an N in front of my propyl. All right, so I'll have N-propyl, which means normal, which means straight chain. And then you have your isopropyl, the isomer of that normal propyl group. All right, you're going to do the same thing here with butane, but they left a couple off. So you have your N-butyl group when you take it off of the end, the long normal chain. All right, so you take the H off the end, you have a normal butyl group, or the book will just call that butyl. But you could also take it off of one of the CH2s, which are the same. So if we did that, we would have a different alkyl group, which you need to know. So if we take a CH3 and then a CH, now we want to connect something there. This is called the sec-butyl group, or a secondary butyl. Notice down here, we're going to see a tertiary. This is a secondary butyl. All right, and so they will call that one sec-butyl. So a secondary butyl is sec-butyl. So you need to know that if you take the H off of the second carbon, it is then a secondary butyl carbon. All right, now with your butane, you have an isomer of butane, which of course is called isobutane. But if we number it and name it like we would do any alkane, we number it 1, 2, 3. Longest carbon chain is 3. So that is a propane. All right, and off of carbon 2, we have a methyl group. So this is a 2-methyl propane. All right, and so they only take the H off of the center one in this table 23.6. All right, and so they have a group coming off of the center carbon. They do not take a hydrogen off of one of these CH3s. All the three of these are the same. So we need to show that one as well. All right, but when you take it off of the one in the center, that is called a tertiary butyl group, or I will always call that a T-butyl group. And some people will put tert-butyl. So if you see tert-butyl, they're abbreviating tertiary, but not all the way down to the T. All right, so tertiary butyl, I've seen it as tert-butyl or T-butyl. All right, but we could take it off of the end CH3. So CH3, then CH, and CH3, and now CH2. So we take the H off of one of the CH3s. And this one is called the isobutyl group. All right, so the isobutyl, anytime you have a CH, all right, a CH that is bonded to two CH3s, that is always going to be an iso. All right, when you have it's always a CH except for, let's see, that you always have a CH with two CH3s. So right here for your isopropyl, you have a CH bonded to two CH3s. Now the alkyl group name is then the total number of carbons. So this one has total number of carbons 3, so that is isopropyl. This one has a total number of carbons of 4, and so that is an isobutyl. If you had a CH3 with a CH and a CH3, all right, so that's your isopropyl. You add another CH2, now you have your isobutyl. If you add another CH2, now you have your isopentyl. You add another CH2, now you have your isohexyl, and so on and so forth. So this would be an isohexyl group. All right, so it has this iso, and then to get the name, it's the total number of carbons. So that's 3, 4, 5, and 6. So that is an isohexyl group. All right, so you have all of your iso groups. You have all of your normal groups. So if we go back and we take an H off of here, all right, so we take that and make that a 2, and that's going to be bonded to something. All right, so that is an N-heptyl. Again, to get a group, your ANE is then converted to YL. So if you had a normal heptyl group, you're just taking off the last last H off of your compound. So that's a CH2. It has to be bonded to something else. All right, so you know all of your N-hexyl, simply you take off the last H, and octyl, and nonal, and decyl, and you also know all of your isos. So you have this has to end in this. This has to be the end of it. And then all CH2s after that, you simply count the number of H's or number of carbons. When you have a total of 6, it's isohexyl. If you had 5, it's isopentyl. If you have 4, it's isobutyl. If you have 3, it's isopropyl. All right, and then one more that we're going to need to know, and that is benzene. So this one does not follow the rules, all right, because benzene doesn't end in ANE, and so we're not changing it to YL. All right, so this has 6 hydrogens on it. All right, so if we put all 6 hydrogens on our benzene, all right, what we want to do is we're going to take one of these H's off and make it an alkyl group. Except this is an aryl group because it is aromatic. All right, and so when we take one of the H's off, and it has to then be bonded to something, so we show it with a little squiggle that it's going to be connected to something. So sometimes you'll put just a little squiggle here, so that's going to be bonded to something else. That carbon does not have 4 bonds until it's bonded to something else, but the 5 H's are still here. And you need to know that this group is called the phenyl group. All right, so the phenyl group is a very important group in organic chemistry. So you have to know that you have benzene, that is a compound. You have phenyl, that is a group. So you can have a bottle of benzene. You cannot have a bottle of phenyl. Phenyl is a group. You can have phenyl alcohol, you can have phenyl a lot of stuff, but you can't just have phenyl. That is a group. That carbon does not have 4 bonds. All right, so again, you're looking for the longest continuous carbon chain. So you can go 1, 2, 3, 4, 5, 6, 7. That is not the longest chain because if you went 1, 2, 3, 4, 5, 6, 7, 8, that is longer. So this is an octane. All right, and of course you can number it this way, where off of 5 you have a N-propyl group, or 1, 2, 3, 4, 5, 6, 7, 8. You can also number it. You can go right to left, left to right. The way that you go is the one that gives you the lowest number for your first alkyl group. And so if we go from left to right, that number is 5. If we go from right to left, our number is 4. 4 is a smaller number. And so I'm going to say that this is a 4N-propyl octane. That's one word, octane. So N-propyl octane. Now, they're not going to put the N. They're just going to say 4-propyl octane, and that's fine. I like to be specific. I am not talking about the isopropyl group. I'm talking about the N-propyl group. All right, so 4-propyl octane or 4N-propyl octane would be the name of that. Either answer would be given full credit. All right, condensed structural formula of 4-ethyl 3-methyl heptane. So I go, when I write my condensed structural formula, 1, 2, 3, 4, 5, 6, 7 carbons. Off of carbon 1, 2, 3, 4, I have an ethyl. Off of carbon 1, 2, 3, I have a methyl. All right, so that is how I would like to write the condensed structural formula of 4-ethyl 3-methyl heptane. But the way we need to write it is a CH3, CH2, and then CH, and then in parentheses CH3, and then CH again, and then in parentheses CH2, CH3, and then CH2, CH2, CH3. All right, so actually this is the hard way to see what the structure is. And so on the test, when you're writing it on a computer, you have to write it in a straight line just like that. If I'm drawing the problems, I'm going to draw them in this form. If I am typing them, I'm going to type them in this form. So regardless, you need to know how to use both of these methods. If you're writing your answer, I don't care which way you write it, but you have to be able to understand the question written this way or the question written this way as well. All right, and so again, 1, 2, 3, 4, 5, 6, 7 is your longest carbon chain. It's harder to see that here, but 1, 2, 3, and then you have to know to skip this one because that's going down. 4, you got to skip these two because that's going up. And then 5, 6, and 7. So I feel like it's a lot easier to see when you write it out in this form. All right, then off of 3, you have a methyl. Off of 3, here's your methyl. Off of 4, here's your ethyl. Off of 4, here is your ethyl. So anytime you're given a problem like this, you should write it out into something that looks like this, or something where you can see your longest carbon chain much better than written that way, because I'll have a lot of people just count all the way across, and they'll call that decane because there's 10 carbons. That is not the correct answer. All right, so now we know how to name our alkanes, our alkenes, and our alkynes. And we also know all of our alkyl groups, and now we know orthometapara. All right, and so here on this example, we have a 3-ethyl, 1-methyl benzene. I'm not real sure I agree with that name, but I would give that full credit since it's sitting right here looking at me. All right, but of course you could write it as a 1, 2, and a 3, which is the correct way to do this one. All right, so it doesn't matter if you go here or here. The numbers are the same. They're 1 and 3. However, when it doesn't matter and your numbers are 1 and 3, then you default to alphabetical order. All right, so the ethyl alphabetically is going to come first, and it could be a 3 or it could be a 1. It doesn't matter, but it does. You would go with the alphabet and give it the lowest number. And so this should be a 1-ethyl, 3-methyl benzene. Now, or you could just say this is meta ethyl methyl benzene. All right, and so meta means 1, 3. And so 1 and 3, you have an ethyl, you have a methyl. Regardless, I'm not going to count the number wrong since they're showing the numbers wrong here. But if you put methyl first and ethyl second, then you're going to miss a point because it has to go in alphabetical order. Ethyl must come before methyl. And when it doesn't matter, then you put the lowest number with the ethyl. Sometimes you cannot do that. But if you can, it doesn't matter. If you go 1, 3 this way or 1, 3 that way, then you go with alphabetical order. On this one, you cannot use orthometapara because you have 3 substituted groups. You can only use orthometapara when you have 2 and only 2 groups. And so the lowest numbers here are 1, 3, 5, and that is a trimethyl benzene. All right, so here is where you would need to know your phenyl group. All right, so here you have your longest carbon chain of 1, and so that would be methane. And off of this methane, we have a phenyl and we have another phenyl. So we have a diphenyl methane. And if you want to say this is a 1, 1 diphenyl methane, I'm not going to count that wrong, but since there is only 1 carbon in methane, of course, it's coming off of that only carbon. All right, so you do not need the 1 and 1, but it is a diphenyl methane. Again, I would not count off if you put numbers that were not necessary. If the numbers are necessary and they're not there, well, then you have the wrong answer for the compound. All right, All right, so the black balls are the carbons, and then the hydrogens are blue. All right, and so when you are writing your molecular formula, you have 1, 2, 3, 4, 5 carbons. So that is C5. And then you just add them up, or you know it's an alkene, and you have 10 hydrogens. 3, 4, 5, 6, 7, 8, 9, 10. Again, simply count them, and you got H10. But you should know that the general formula for an alkene is CnH2n. So once you counted 5 carbons, then you know if it's an alkene, you have 10 hydrogens. Your condensed structural formula. All right, so that's basically putting the H's. So you have CH3, and then you have a CH. Then you have your double bond. You have another CH, and then you have your CH2, and then you have your CH3. All right, and so now we want to write the name. All right, and so this is a 1, 2, 3, 4, 5. So the longest continuous carbon chain is 5. All right, so that would be pentane, except we have a double bond. So that is a pentene. All right, and then the lowest number for the double bond, as long as you started from the end closest to the double bond, which we did, it would be a 2. Of course, if you went this way, 1, 2, and 3 would be the number that starts the double bond. And so 2-pentene, and you think you're done, except you have to know for your alkenes, you have a possibility of being a geometric isomer, and this one is a geometric isomer because on the left side here, you have a methyl and a hydrogen. That's different. On the right side, you have an ethyl and a hydrogen, and those are different. So you have geometric isomers for this compound. And since the H's are on the same side, we have a cis 2-pentene. And so putting it in a condensed structural formula where you're not supposed to show a carbon-hydrogen bond, it's more difficult to see that it is a cis. So you would need a detailed structural formula showing all the carbons and hydrogen bonds to show clearly your cis bond. Now, if I'm writing it the way I like to write it, 1, 2, 3, 4, 5. Oh, I put too many. All right, so let's go here. So I have 2, 3, 4, 5, and my double bond is here. All right, and so here is my condensed structural formula. Now this one is actually showing cis because our carbon here has 3 directions, and so the bond angles are all 120. So when I draw it this way, here's a 120, all right? So I have to have something here, which is an H, all right? 120 and 120. Same thing down here, 120. All right, so I'm not going to show these H's, but I know they're there because I have to have 4 bonds to carbon. I have 3 directions, and that means the bond angle is 120. And so I have a double bond, and these H's have to be on the same side. And so when I draw my structure that looks like that, that is showing a cis double bond. If I wanted to show the trans double bond, then I would show it like this. So this is showing it cis, this is showing it trans, because I know my bond angles are 120, and I know I have to have 4 bonds to carbon, so I know this H is here, and I know this H is down here. And so I show it as a cis and a trans. A lot of times when it is cis and trans, I will actually put in the H's for the double bond, clearly showing that that is cis and clearly showing that that is a trans. All right, and so more things to memorize, and that is this giant list of functional groups and how to name them. All right, so this is table 23.7. All right, so here you have a bunch of organic functional groups. Now, the functional group is the color blue. on the test, I'm going to have you circle the functional group. So it's going to say circle the functional group. And so if you had this, you would circle the chlorine, or if you had this one, it would be bromine. It is an organic halide. So I will say not name the functional group because that is a chloride, that's a bromide, or a chloro and a bromo. But we're going to name the class of compound. All right, so the class of compound is an organic halide, or you could call it an alkyl halide. All right, because R is an alkyl group. So R is the abbreviation for any alkyl group. All right, so it could be methyl, ethyl, propyl, isopropyl, butyl, T-butyl, sec-butyl, isobutyl. It could be any of the alkyl groups. So R is just generic for an alkyl group, which means a carbon group. All right, and so then you would have to name it. Let's say this one. So if it said if this one's on the test, it's going to say circle the functional group, and so you would circle the bromine. It would say name the class of compound. You would either say organic halide or alkyl halide. And then it would say name this compound. All right, and so you have to find the longest carbon chain with the lowest number for the BR. All right, and so that means you're going to number it this way, the end closest to the bromine. And so you have 5, and so that is a pentane. And it's all single bonds, and so you would write pentane, but off of carbon 2, you have a bromine. So that is a 2-bromo pentane. So you would name the group as a bromo, chloro, fluoro, iodo. Those would be the 4 halides that you will see. All right, so that also includes, you'll see fluoride, halide, also so RF and RI. All right, so that would be fluoro, that would be iodo, chloro, bromo, ends in an O. All right, so that's how you will name your organic halides. All right, the next one, you would circle the OH. You would name that class of compound an alcohol. And now you're going to have to name an alcohol. All right, so if I go here and let's say I put the OH right there, and let's put something else on here. Let's put a group right there. All right, so here are the naming rules. Longest carbon chain, that is going to be your base name. Now we're in alcohol. Once you recognize alcohol, you're going to drop the E. All right, so if it was pentane, you drop the E, and then you're going to add OL. All right, and so here's one that you already know. So if you had CH3, CH2OH, all right, longest carbon chain is an ethyl group, so it's ethane. You would drop the E and you would add OL, so that is ethanol. So CH3, CH2OH is ethanol, all right, which follows the rules. You don't need a 1-ethanol. Again, if you put a 1-ethanol, I'm not going to count that wrong, but there's no such thing as a 2-ethanol. So you don't need the 1. All right, so you have to have the lowest number for the carbon of the OH. You always number at the end closest to your OH. So you want to go at this end. 1, 2, 3, 4, 5, 6, 7. And so you have a heptane. All right, I'm not going to put the E because I know I have an alcohol. I'm going to drop the E of heptane and add OL. So I have a heptanol. All right, now you have to put the number for the alcohol. That is carbon number 3. So this is a 3-heptanol, similar to how we do our alkenes and our alkynes. All right, so the lowest number for the carbon that has the OH. But I added another methyl group off of carbon number 6. And so you would also have to put your 6-methyl. So this is a 6-methyl. 3-heptanol would be the name of that alcohol. So when you do alcohols, you drop the E, you add OL, lowest number for the carbon that is connected to your OH. All right, your ethers. Couple of ways to name the ethers. I'm just going to stick with one, the most common way, and that is to name it as an alkyl ether. And that is 3 words. All right, so if we had the most common ether like this, if somebody wants alcohol, all right, they said, I'm going to have an alcoholic beverage. They don't want methanol in there to make you go blind, and they don't want other alcohols that are, a lot more dangerous. They want ethanol. It's understood that when they're drinking alcohol, they're drinking ethanol, not some other alcohol. Same with ether. If somebody says, I want a bottle of ether, they don't want one of a million bottles of ether that they have. They want diethyl ether. And so if we have CH3, CH2O, and then CH2, CH3, that is diethyl ether. 2 words. Okay, you're not going to say ethyl ether. You're going to say diethyl ether. And note here that diethyl ether is simply ether. So if somebody says, I want the ether, they want the diethyl ether. All right, so there's many ethers, but the most common ether is a diethyl ether. And so we're going to name that by alkyl ether, 3 words, and the alkyl groups have to go in alphabetical order. All right, so if we had a CH3, O, CH2, CH3, all right, so now we have a methyl, and we have an ethyl, and we have an ether, and if you wrote it that way, you would lose a point, because you have to put it in alphabetical order. Not the way that it shows up, it has to be in alphabetical order. And so that is an ethyl, and then a methyl, and then an ether. So that is an ethyl methyl ether. Ethyl methyl ether. All right, so here we have an aldehyde. Now, aldehydes, when you see an aldehyde written as a condensed structural formula, they're going to have it as an R, and then you're going to see it as a CHO. All right, so that is right here on the left side. This is your R, and that is a CHO. Because the only way that you can get 4 bonds to that carbon is you bond to the R group, you're bonded to the H group, that's only 2 bonds. So that tells you that that CO has to be a double bond. Carbon always will have 4 bonds. All right, so aldehydes, the way we're going to name them. First thing is you don't have to worry about what side to start with. This carbon is always carbon number 1. So you're not really looking for the longest continuous chain. You are, but you know where you're starting. You must start at that carbon, and now you're looking for the longest continuous carbon chain. All right, and to name it, we're going to drop the E, and we're going to add AL. All right, so there you have to be very clear when you're writing an A versus an O, because if you wanted ethanol and somebody gave you ethanol, you're going to be in big trouble. So make sure you are clear with your letter A and O here. There's only one difference between one letter difference between an ethanol and an ethanol. All right, so an ethanol is going to be a CH3, C double bond O to H, because your longest carbon chain is 2. That would be ethane. But you're going to drop the E and you're going to add Al. And so this is ethanal. And you never put a 1 for an aldehyde because they're always a number 1. You must start at number 1. So you might lose a point on any aldehyde where you put a 1 because no aldehydes get a number. It is always carbon number 1. All right, but if you had, let's say we had something like this. All right, so you have to start here at 1. All right, then you have 2 and 3 and 4, and you might want to go this way, but that would be the wrong way because then you would stop at 5. This is not a 4-ethyl, this is a 4-methyl because 5 and 6 go up here. And so this is a hexanal. So it's a hexane. There's 6, longest carbon chain, with this carbon being carbon number 1. We drop the E, we add Al because we recognize our aldehyde functional group. And then off of carbon 4, we have a methyl. So that is a 4-methyl hexanal. That's one word, 4-methyl hexanal. All right. Now our ketone. So if you have a C double bond O, and now it's not connected to an H, it's a carbon on both sides. Now we have a ketone. And so here it's the lowest number possible. All right, so it's not going to be a 1. If it's a 1, then you're an aldehyde. But you need to have the lowest number for the C double bond O of your ketone. To name it, you're going to drop the E, and you're going to add ONE. All right, so ketone. So we're going to end it in ONE. All right, so the most common ketone has 3 names. So 1, the UPAC name, longest carbon chain, is 3. It doesn't matter which way you number it. So that is a propane. But we're going to drop the E of propane and we're going to add ONE because we recognize it as a ketone because of its functional group. And so we have propanone, and then we have the lowest number for the C double bond O, and so that is a 2-propanone. It would be correctly named as simply propanone because there's no such thing as 1-propanone, because 1-propanone would be an aldehyde, and that would be a propanal. All right, but 2-propanone is full credit, just propanone, also full credit. But no one calls it propanone or 2-propanone. Everyone will call this acetone. So that is a ketone. That is your, what we call the ACE ketone, the simplest ketone. That is your acetone with 2 methyls on both sides, which it could be named that way as well. It could be named as a dimethyl ketone. All right. Again, everyone's going to call that acetone. If you buy it, though, the bottle is going to say 2-propanone. The next one is carboxylic acid. So in blue, you circle the C double bond O connected to an OH. All right. So that is a carboxylic acid. Carboxylic acid is not the name of the functional group. The carboxylic acid is the name of the class of compound. All right, and to name this, we drop the E, we add oic acid. All right, so if we stick with something simple, CH3, C double bond O, OH. And this one as well, this is always carbon number 1. All right, so you have 2 for your longest carbon chain. So that is ethane. But we're going to drop our E and add our oic acid because we have our carboxylic acid functional group. So that is ethanoic acid. All right, so again, if we write this out, we memorized this one last time, which was first semester, HC2H3O2. That is the formula for ethanoic acid, and we see that that is called acetic acid. So ethanoic acid is acetic acid. Acetic acid is the common name. Ethanoic acid is the UPAC name, which is the systematic naming system. All right, so that is how you will answer how to name a carboxylic acid. Drop the E, add oic acid, longest carbon chain. Carbon number 1 is always the C of the C double bond O. All right, esters are very difficult to name. They are 2 words. All right, you're going to name the alkyl group off of the O first, and then you're going to name the rest as a deprotonated carboxylic acid. All right, and so to remember how to do that, when we take the H off and we have C2H3O2 minus, that was memorized. That was actually on our flashcards first semester to memorize that that is acetate. And when we put the H on it, and we knew that acetate was -1, so we needed the 1H. So we put the 1H on it, and we knew that the ATE went to an ic acid. All right, here we're going to do it backwards. We are going to have our ic acid. We're going to take the H off, and it's going to go to 8. All right, and so this is going to be named as a deprotonated carboxylic acid. All right, so if we just put a simple one up here, say CH3, C double bond O, then CH3. All right, so the group coming off of the oxygen is named first, and that is methyl. All right, and this is 2 words. When you name this, it is 2 words. First word is the group coming off of the O, and then the second word is the deprotonated carboxylic acid. All right, and so this one we have right up above here. So if we did the common name, it is the acetate. So when we take the H off of acetic acid, it is acetate, so methyl acetate. Or if we use the UPAC name, we take our ic acid, remove that, and add ATE. And so this is methyl ethanoate. All right, so we removed the H, and so our ic acid becomes 8. All right, so it's the reverse of how we did the Gen Chem. We memorized all the 8s, then we put on the H's, and we knew that that converted to an ic acid. Here, we're taking off the H, and so we are then converting the ic acid into an 8. So it is the group coming off of the oxygen, that alkyl group is named, and then you name the rest as a deprotonated carboxylic acid. All right, your amines. So you have 3 different amines listed here. The first one, the nitrogen, is connected to 1 carbon, and that is a primary amine. The second one, you're connected to 2 carbon groups, and that is a secondary amine. And on the third one, you're connected to 3 carbon groups, and that is a tertiary amine. All right, and so to name these, we're going to go with this naming system, and that is alkyl, 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 amine. And the only time you're going to have 3 alkyl groups named is if you are tertiary and all of them are different. All right, so if I put for this R group, let's say I put a CH3. So this is simply methylamine. All right. If I have CH3 and CH3 again, now I have dimethylamine. Not methylamine, dimethylamine. And if they're all three methyls, you would have trimethylamine. All right, but what if I put one as a CH3 and I put one as a CH2CH3 and I put one as a CH2CH2CH3? All right, so now I have three different groups, and so I will need to use the naming system of alkyl, alkyl, alkylamine. All right, but they have to go in alphabetical order. So you have an ethyl, a methyl, and a propyl in alphabetical order. So you would have ethyl, then you would have methyl, and then you would have propyl, and then you would have amine. So that is an ethyl, methyl, propyl, amine. That would be three different R groups on the nitrogen. So if you have more than one of the same, if you have two of the same, you have to use di. You would not say methyl, methylamine, dimethylamine. Again, if you have three of the same, you would use the prefix tri. All right, for your amide in blue, for whatever reason, they put that H in blue, and that's fine. They can do that, but if you're circling this H, now you're talking about a secondary amide. And then there should be another one listed where you have a C double bond O to N, and you have two R groups, and that is a tertiary amide. And then you should have another one where you have no R groups, and it's simply an NH2, and that would be a primary amide. Not sure why they listed only the secondary one, but you have primary, secondary, tertiary amines. You also have primary, secondary, and tertiary amides. All right, and so the groups coming off of the nitrogen get a capital N. All right, so you will have N-alkyl, N, and N, when you're putting dashes with this capital N, you're treating it like it is a number, and it is a capital N. A capital N means it's coming off the nitrogen. N-alkyl, N-alkyl. Then you would name your left side, longest carbon chain. This one has to be carbon 1 when you're doing the longest carbon chain. And then you're going to drop the E and add amide. So then you drop the E and you add amide. All right, so let's do a name of an amide. Write it up here. All right, so let's try this one. CH3, C double bond O, and then I have an N, and I have a CH3, and I have a CH3. So that is an interesting one to do. And so you have an N-methyl, and you have an N-methyl. All right, so again, the capital N is like a number. And so you will say N, comma, N, and then you will say dimethyl. If one was an ethyl and one was a methyl, you would say N-ethyl and methyl. They would go in alphabetical order. When they are the same, you will say N dimethyl. And then you have on the left, your longest carbon chain is 2, so that is ethane. So here would be ethane. Except I know that I'm going to drop the E of my ethane. I see that I have an amide. So my functional group with a C double bond O to an N, that is an amide. So I drop the E and add amide. So that is NN dimethyl ethanamide. And that is all one word. And you see that this nitrogen is connected to 3 carbons, which means that this is a tertiary amide. All right, so when we look at our alcohols and ethers, so our alcohol, note that that's why the table is wrong. The OH group, if you're naming the functional group, that is a hydroxyl group. All right, I'm not going to ask you to name the functional group. You're going to circle the functional group, OH, and then you're going to give the class of compound, which is an alcohol. Will not have to write that OH group is called a hydroxyl group. All right, so here they're giving the UPAC rules. Again, longest carbon chain, lowest number for the carbon that has the OH. You drop the E, you add OL when you name your alcohols. All right, but just like we had primary, secondary, and tertiary amines and amides, we are also going to be having primary and secondary and tertiary alcohols. So we're talking about the carbon that contains the OH group. That's the carbon that we are looking at. If this carbon is attached to one other carbon and two H's, then you have a primary alcohol. If your carbon that is connected to your OH is connected to two other carbon groups, all right, and so alkyls can be the same or they can be different. So normally the first one they put is R, the second one they'll put is an R prime. R prime and R could be the same or they could be different. That's just the way they do it. All right, so this would be a secondary alcohol. And then if your carbon that contains the OH is connected to three carbon groups, three alkyl groups, which they will normally label as R and then R prime and then R double prime. And those could be the same, they could be different, whatever, it doesn't matter. But then you would have a tertiary alcohol if that carbon was connected to three other carbons. All right, so you'll have to label your alcohols as primary, secondary, tertiary. Your amides will be listed as primary, secondary, tertiary. You also have to do your amines as primary, secondary, and tertiary. Oh, claim to fame for some of our groups here. Your amines. Amines are the most basic. All right, and so when you're talking about you want to do something that has a high pH, you're looking for an amine. You want something that's going to remove a proton. You're looking for an amine. The amine organic functional group is the most basic. The most acidic will kick you in the head because it says acid in it. Of course, the most acidic is the carboxylic acid. That's the most acidic. And in chapter 24, when we are doing our biochem, we're going to have amino acids. All right, that's going to have an amine, the most basic group, and a carboxylic acid, the most acidic group, in one compound. All right, so here is a list of alcohols and the label of primary, secondary, tertiary. So to name it, you have to give the carbon that contains the OH the lowest number. So you always start numbering from the side closest to the OH. In this case, that would be 4, which would be butane. This is an alcohol, and so we drop the E and we add OL. So we have butanol. But you have to give the location of that OH. So this is a 1-butanol. Here, you go to the side closest to the OH. Longest carbon chain, again, is 4. So that is a butane. You drop the E, you add OL because you have an OH. You have an alcohol. And so you give the location of that OH. So that is a 2-butanol. All right, and so on this one, you don't give the number 1 for that carbon because then your longest carbon chain would be 2. That is not the correct number. Longest carbon chain here, continuous chain, is 3. And so that is a propane. We drop the E, we add OL, we have propanol. The location of that is on carbon 2, so that is a 2-propanol. But also on carbon 2, you have a methyl, not part of your longest carbon chain. So a 2-methyl 2-propanol. So since this carbon is connected to only one other carbon, that makes this one primary. And when this carbon, and looking at the carbon connected to the OH, is connected to two other carbons, that makes it secondary. And this carbon connected to the OH is connected to three other carbons, and that makes that a tertiary alcohol. So you'll have to label your alcohols as primary, secondary, and tertiary. All right, so of course, water is H2O, and if you have one carbon group, now you've got an alcohol, two carbon groups, and now you've got an ether. And again, the first one they'll put on as R, the second one they'll put on as an R prime. All right, so this, okay, so you're going to have two ways to name your ethers, and I will accept either way to name your ethers. All right, so here you have methyl, and here you have propyl, and that is an ether. So if you name this as methyl propyl ether, that is full credit. If you name it as methyl N-propyl ether, that is full credit. Now, when you're doing the UPAC name, you always look for the longest carbon chain. And so the longest carbon chain here is 1, 2, and 3. All right, and so that is a propane. Off of carbon number 1, that is where you have an OCH3. All right, and so this is a methoxy. And so you have a 1-methoxy propane. So I'm not looking for the name 1-methoxy propane. I'm looking for the name methyl propyl ether. But of course, I would accept either name when naming them. If it's multiple choice, I'm going to put this name if you're picking it out from a multiple choice. But if I say to name it and you give this name, that is fine. I'm really looking for methyl propyl ether for the name of an ether. All right, so if we're going to name this, all right, so this one is relatively easy to name. This one is not tricky. All right, so you have to number it so that you are at the side closest to the OH. So that is a 1, 2, 3, 4, 5, and 6. It would have been a lot trickier if this number of carbons down here was not the same as up here, because you could have went 1, 2, 3, 4, 5, 6. It's exactly the same. All right. So if we go straight across, which is what people like to do, so there's our continuous chain, and so that is our hexane. But we know it's an alcohol, so we know to drop the E of our hexane and add OL. We have to give the location of that alcohol with the lowest number possible for your carbon, which we numbered it this way because it was closest to the OH. So that is a 3-hexanol. But also off of carbon 3, we have this 2-carbon group. And so that is a ethane, but it's an alkyl group, and so it is an ethyl. And so we have a 3-ethyl, 3-hexanol. And now to distinguish this one as primary, secondary, tertiary, again, we're looking at the carbon that is connected to the OH. It is connected to 3 other carbons, and so this is a tertiary alcohol. All right, now I want you to give me the name of this. All right, so that would be a hard question. Well, one, because we haven't covered it yet. So this we haven't gotten into yet because what's different about this one is we know we're going to start numbering it closest to the OH. So we know that's 1, 2, 3, 4. And then some people will say 5, 6, and then they'll just name it from there. Other people will say, but if I go up here, it is also 5, 6. So here is where you have a tie. The longest carbon chain is a tie. You go straight across at 6. If you go to 4 and then you go up, it's also 6. When you have a tie, you will go to the direction where you have the most substituted groups. So when you have a tie, you go the direction with the most substituted groups. All right, so if we went straight across, we only had the one group here off of carbon 4. If we go up, we would have a group off of 4. We would also have a group off of 5. And so the way that you will go is this way. All right, so that gives you a group off of 4 and a group off of 5. If you went straight across, you only had a group off of 4. So you'll go in the direction with the most substituted groups, which will be then the smaller groups as well. So instead of an isopropyl group, a bigger group, you're going to have one methyl and you're going to have one that's ethyl. All right, so we know it's hexane, but we know it's an alcohol, so we know to drop the E and add OL, and the lowest number for that is a 2. And then off of carbon 5, you have the ethyl. Off of carbon 4, you have the ethyl, and off of carbon 5, you have the methyl. And of course, I did not put the ethyl first because of the number 4. I put the ethyl first because of the alphabet. Ethyl will always come before methyl. Doesn't matter what the number is. And you see that this carbon is connected to other carbons. This is a secondary alcohol. All right, we will continue this on Monday.